right, so just wanted to do an introduction into constructions. I don't know if it was the Egyptians or the Greeks who really deserve the credit for it, but it's pretty crazy if you think about you have like a compass and a straight edge. Like, how would you make a compass and a straight edge if I just dropped you off in the middle of nowhere? It'd probably be pretty difficult to do. So a lot of these things were done with like strings and vines and that kind of a thing, and the arc. So if you think about putting a stick at the end of a string and holding the other end without the stick, and then sort of making an arc in the ground. That's really what we're talking about. And I know it looks different, but that's really what we're talking about with the straight edge, right? Like there's a string here with the stick in the ground. We plant this part in, and then we just go ahead and we sort of mark an arc in the ground. And we get that arc. And one of the things I really want you guys to be clear about is when we look at arcs, a lot of people see a curve. And I mean, obviously you see a curve, and I don't know if this is going to allow me to do this, but if you think about it, really what you've done here is you have drawn a radius. And what's important about that is all of these radii are the exact same length. And we're going to exploit that logic when we do constructions. For instance, you can see I've made an isosceles triangle right here. I know it's isosceles because I know that this side length has to be the same as this side length. And then we go from there. And we really only have two moves. We have a perpendicular bisector, and we have an angle bisector. And I'm going to show both of these. Once I'm going to show it with congruent triangles, so you know that they are in fact what we say that they are. And then the next time I'll do it just real quickly, just sort of the short way, because we don't always show the triangles. As a matter of fact, most of the time we don't show the triangles when we make a perpendicular bisector or an angle bisector. So when I go here, yeah, that didn't. I'm kind of getting a feel for this thing, so please be patient with me. So if we go here, what we can do here is we can plant this on one end of a line that we're trying to perpendicularly bisect. Don't forget, perpendicular means 90-degree angles, bisect means cut in half. So we're going to try and cut this thing in half. So let's see if we can do that. I'm going to make an arc here up at the top. The important thing about this arc is that the arc is the same. You'll notice I have this thing locked. And that, I don't know why this thing sort of spins around so much on me, but that it's the same arc. It doesn't matter. It just needs to be the same arc, and it needs to be more than halfway. If it's not more than half of the length, then the arcs won't meet. So you can see what we're trying to do is have these arcs meet. And we're trying to do that for a reason. And again, I don't know why this thing is so like finicky on me, but so we get something that looks like that. So what's important about these arcs that I made is obviously they make a point in those arcs, and those points are important because if I connect from here to here and from here to here, this arc is the same as this arc, right? I'm trying not to clutter this, but I know that this has the same length as this. And since I locked my compass, I also know that the arc I made in this direction is also the same. So this line segment from here to here is the same as this line segment from here to here. And again, I know that they all have the same length. So if you think about this, I have already created congruent triangles because of side, side, side. I hope you would agree that these are congruent triangles because of side, side, side. And if these are congruent triangles because of side, 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 I know because of CPCTC that the corresponding parts are also congruent. So I know that these angles have to be the same. I know that these angles have to be the same. And you'll notice I'm going to put one arc in both because this is across from the same side length. So essentially I have an isosceles. Not only are these congruent triangles, but they're congruent isosceles triangles. So isosceles triangles have two sides that are the same, but also two angles that are the same. Now I also know that these angles are going to be the same as well, but I'm going to end up having to cut those in half. So that's not like that big of a deal. So what I can then do is I can also draw this. And again, now I have these congruent triangles here, right? This one and this one. So I have side, side, side congruence. And now I can also say, hey, these angles must be the same because of CPCTC as well. So I'm going to go here and I'm going to mark these because of CPCTC, that these angles are the same as well. So if you look at what we're looking at right here, we have 4 congruent triangles. 1 tick, one side, 2 ticks, 1 tick, one side, 2 ticks, 1 tick, one side, 2 ticks, 1 tick, one side, 2 ticks. So I have 4 small congruent triangles right here. And that's important because I know because of CPCTC, this side is across from 2. So this side length, I guess I'll give this one a side length of 3 here. This can kind of go away. That was from the other one. So that has 3, and this is going to have 3 as well. So there we go. That must be the midpoint. If this distance is the same as this must be the midpoint. So I've bisected the side length. I've cut it in half. This half is the same as this half. But not only that, but these angles also correspond. If this angle is the same as this angle, and this is a straight line, well, these must both be equal 90. 90 plus 90 is 180. They have to be the same because of CPCTC. So there we go. We have our perpendicular bisector. This line has been cut in half, but not only has it been cut in half, it's been cut in half at a 90-degree angle. So pretty cool. Again, triangle congruence makes this true. I'm going to go ahead and clear this out and just do a real quick one so you can see what I'm talking about, that normally we don't draw the triangle. So I just want you to see how quick this normally would be. I'm going to go here and I'm going to make an arc. As a matter of fact, you can make it go the whole way if you want. I'll go over here and I will make that same arc. Again, it's important that these are locked, that this length is the same as this length. Now what I can do is I can just, you can see I'm not great with this tool. I can just go here and I can connect this. I can connect these points because what I've done here, and again, all the triangles are gone, but I have CPCTC. The distance from here to here is the same as distance from here to here, and these angles are also the same. So I have a perpendicular bisector. So pretty simple process. One arc, connect the points. It's literally 3 steps, right? One arc, go to the other side, make another arc, and then connect those points, and you have a perpendicular bisector. The other move that we're going to do a lot of is an angle bisector. So I'm going to show you an angle bisector again with triangle congruence so that you can be sure that indeed we are sure that we've bisected an angle, and then I'll show it to you again quickly. So here's just any old angle. It doesn't really matter. We are going to go here and we are going to, again, it doesn't really matter what arc we use. What matters is that we use the same arc. So I'm going to go here and I'm going to make this arc. So something important just happened here. I have made congruent lengths. That length is the same as that length. Now I'm going to go here, I'm going to grab this, and I'm going to do it again. So I will make an arc here, and again I will go down here and I will make the same arc. And what we've done here is, again, we have come up with congruent sides. I didn't move this arc. This arc has to be the same as this one, but it doesn't have to be the same as these two, but it's easier just to leave it the same and make them all the same, again, to make that isosceles triangle. So now if I go here, I can say, hey, look, side, side, side congruence, right? Side, side, side congruence, this triangle is the same as this triangle, and if that's the case, CPCTC says these angles are the same, and that's what I wanted to do, was cut this angle in half. So I've cut this angle in half. Again, I will show it to you quickly. You can watch these again. I'm sure there's a million videos explaining triangle congruence in this that are way better than this one, but I wanted to make one. So again, we start with this angle. We're going to go here. we're going to make our arc. That's the first thing I'm going to do. I'm going to go here, second step, I'm going to make an arc, drag this down here. Third step, I'm going to make an arc. And then the last thing I'm going to do is I'm going to connect to that point. And now I know that I have indeed bisected this angle. Again, I think just a tip of the cap to the Greeks or the Egyptians, whoever deserves credit. I think they both probably deserve credit in their own way. I think it's formalized by the Greeks, but the Egyptians were using it. I could be wrong on that, but that's what I believe. But anyway, just think about how difficult it would be to come up with a perpendicular bisector using a string and a stick, or to bisect an angle and cut it in half, and know that you're right, and know that you can prove it with triangle congruence. I think it's pretty amazing what they accomplished. So again, this is an intro video. From there, you can kind of look and see some of the stuff it asks you to do, but I definitely wanted to start with this.